Hey guys, starting out with the answer key for our most recent lesson. In case you forgot to correct in class, please feel free to press pause to keep the answer key up for as long as you would like. The second part of the answer key, it looks like number 11 is a little bit difficult to see. We could go ahead and enter here. Nine over 11 H is what you should see. Diving right into our content, it really is your job to decide what you're going to write, but you should always work through the examples. This is lesson 3.2, solving equations with tables and graphs. As always, please work through the examples before advancing the slide or, I guess, continuing the video. We've done this before, essentially, when we took a look at Sharon's pool, just to remind you of the situation we see here. With Sharon's pool, her pool is filling at a rate. We can see the level of her pool increasing here as we follow the red line. Her pool was filling at a rate of 3 inches per hour, or about 1/4 of a foot for every hour that went by. We actually referenced the idea of using a table to solve an equation, or excuse me, a graph to solve an equation. When we found out that Sharon's pool was 5 feet tall, we made a line that extended over to the pool level, the red line, and we found out that her pool will be filled after 16 hours. Essentially, we're going to be doing the same thing today with tables and graphs. When we want to solve with the table, we have to create a table to track the value of the variable, as well as the expression containing the variable. Generally, we set this equal to y for graphing purposes. Very similar to a guess and check. Let's take a look at an example. We are going to be solving the equation 10 equals 3x plus 4. So as we take a look here, we're going to use a table to keep track of the x value, as well as the 3x plus 4 value, which will be equal to y. Again, for graphing purposes, this will represent our y coordinate. Of course, we are looking for the part where the right side of our table here becomes a 10, as the equation calls for. Just because it's an easy number to start with, I'm going to go ahead and start with my x value being equal to 0. I can make my calculation. 3, substitute a 0 for x, plus 4. Following our order of operations, multiplication comes first. This is 0 plus 4, or 4. This is not the value we're looking for, so we'll try again. I'm going to increase my x by 1 and try out and see what happens when x is 1. Again, substituting for x. Following order of operations, I see 3 plus 4, which is equal to 7. Again, not the value I was looking for, so I'll go ahead and try the next logical x, which would be 2. Substituting in 3 times 2 plus 4. Following order of operations, so we can see that 6 plus 4 equals, yay, it's a 10. This is exactly what we were looking for. So we can go ahead right here and use this row of our table to find out that in this particular equation, x is equal to 2. Now, some of you may have been able to find that answer without using this method. Remember, this is just one of many methods that we will talk about this year to solve equations. If we don't want to solve an equation with a table, but we'd prefer to use a graph, we would essentially start in the same way. We would create a table to graph at least 3 values. The reason why we need 3 values is at that point we can be pretty confident in the pattern of the graph, and therefore we can use that to help us determine the exact solution. We're going to use our variable as our x coordinate, and our y coordinate will be determined by the value of the expression containing the variable. We will graph our pairs using the y-axis to draw a line to determine the correct or x-coordinate, similar to what we saw with Sharon's pool. Here we are asked to solve the equation -1 equals 2x plus 5. Essentially, y equals 2x plus 5. We're trying to find the x that works. We'll go ahead and get ourselves a graph, but before we can graph, well, we do need to, as stated before, create the table that we would like to graph from. In our table, we will need one column to track the x value, that is not working out very well, is it? So we'll go ahead and see what we can do about erasing what we've got here. Please keep in mind that this is a work in progress as we're taking. As you guys know, this is a bit of a work in progress, so I'm going to give this another shot. We have our x column. As well as our y column. Pick any value, I guess, to start with x. 0 is as good as any. So we'll try a 0 here for x. As we substitute 0 in, it becomes apparent that when x is 0, our expression is equal to 5, not -1. So we can go ahead and try another value. Since this value came out to be too high, I might think about decreasing my x value instead of increasing my x value. As we take a look here, I'm going to go ahead and try an x value of -1. After substituting in, it is looking like we still haven't found the value we're looking for. Maybe we went the wrong way. Maybe we should have tried an x value of 1. So we can go ahead and try out an x value of 1 and see what happens here. Looks like our x value of 1 didn't pan out either. We still haven't gotten our value of -1 that we were looking for. So now it's time where maybe we could take a look at the graph. Before we can start the graph, we of course need to draw and pick out our x and y axis, the interval or the scale for the x and y axis. It seems reasonable that we would take an x and a y-axis. This graph should more than likely include all 4 quadrants, not just the first quadrant like we sometimes do, since our graph here represents more than just positive values. Taking a look here, we've got an x and y axis meeting in about the center of the graph space that we have. Chosen an interval of 1. It seemed like it was reasonable, an interval of 1 for both the x and the y axis. It's not necessary to choose the same interval for both axes, but in this case it seemed to make sense. We'll just go ahead and graph each of our points. We've got a point at 0, 5. Locate that on the graph. Go ahead and enter. We've got a point at -1, 3. Locate on the graph, go ahead and enter. We've got a point at 1, 7. From these 3 points, it appears that we've actually got a pretty good line going here. What we would want to do is take some sort of a straight edge and connect the line to see what happens. If we take a look here, our line has been connected, and we can see that the line that represents our equation here, when y equals -1, let's go ahead and get our graph back. We can see when y equals -1, our x value is here at -3. We've just found out that this is true when x equals -3. It's always a good idea to actually substitute your possible solution to make sure that it does in fact satisfy the equation. So let's go ahead and try that. And after substituting in -3 for x, because we believe our solution to be x equals -3, it turns out that this does satisfy the equation. We can see that -1 equals -1, and this is how we can solve an equation using a graph. Let's go ahead and take a look at a real-life example next. Our real-life example. Susie lives in Montana. There's no sale tax there. She bought 5 fountain drinks with a $10 bill and received 55 cents in change. What was the price of one drink? We're going to define our variables. Let's let X be the price of a drink, and we'll go ahead and let Y be equal to the change from the $10 bill. We're going to start this one with a table, since in order to solve with a graph, we need to begin with a table anyhow. Makes sense that we can start this with a table and see how things look. We'll need to begin by creating a table to track our X and Y values. We'll also be tracking our Y, which is the change from the $10 bill after purchasing the 5 drinks. I think it's safe to say that we do not need to test a $2 drink, because if drinks were $2, there would be no change left from a $10 bill. So let's start out with a price of slightly less than $2. Let's try $1.95. As we take a look, if our drink cost is $1.95, we can take 10 and subtract 5 times $1.95, or $9.75, coming up with 25 cents in change. Oh, right away we can see that the drinks do not cost $1.95, but less than that. So I'm going to go ahead and decrease to $1.80. Better yet, let's try $1.90. If we go ahead and subtract from $10 the 5 times $1.90 for the 5 soft drinks, 5 fountain drinks, we would find 10 minus $9.50, or a leftover rate of 50 cents. Again, the drinks must cost a little bit less than this because we have more money left over. It seems like maybe I don't want another 25-cent jump, so instead of dropping my price by 5 cents, maybe I'll try to drop it just by 1 cent. Let's go ahead and try $1.89. In this case, we can see that it has come out to a total of 55 cents left over. We didn't even need to go all the way to the graph. Our table was able to show that each of the soft drinks should be $1.89 in order to have 55 cents change from a $10 bill. Essentially, using a table or a graph can be considered a fancy form of guess and check. May not always be necessary. This is just one of many ways that we have to find a solution to an equation. Please check out the 3.3 notes.